Okay. Yesterday we talked about different types of traffic studies which are listed here. So we talked about the three basic parameters: volume, speed, density, and then we have travel time studies, delay studies, accident, parking, the one for heavy vehicles, pedestrian calibration, and the observational studies. So we talked about all of them a little bit. Then we said that on the basis of the technique which you are using for data collection, then the study can be manual, semi-automated, or automated. Okay, if you are using a manual technique for data collection, it's a manual study. Okay, and if you are using any instrument, that can be semi-automated or automated, and we will talk about the difference between them later on. So for manual studies, we know that they should be short, because if you prolong them, then the chances of errors will be higher. Okay, so in order to restrict the source of error, we keep them shorter, and they have given us a guideline here that don't make the total study more than 24 hours. Keep it less than 24 hours, but I told you yesterday that even 23 hours is not done in a single shift. Okay, so even 23 hours or whatever number of hours you have, it is divided again so that the person is not exhausted and the error is less. What can we do manually? What data we can collect manually? We can collect data about traffic count. We can collect data for speed. We can do observational studies because they are very short and we know what we are looking for. And then we can also do delay studies of intersections because they are complicated. Okay. And later on in some other topic, we will discuss the complete procedure. In manual studies, you have to give time to the observer so that he can take care of his or her affairs. Okay. He is thirsty, he has to make a call, he has to change the sheets, he has to reset the counter, he or she, so you have to give him or her a break. Okay, and the break can be part of the counting period. You tell him this is your total period, and this total period you have 2-3 minutes of break. This is one way, and the other way is that you give him alternate counting and break period. So he will count for 15 minutes, have a break for 15 minutes, again count for 15 minutes, break for 15 minutes, and so on and so forth. Okay, if you are using the first method, which is break within the counting period, then we use the first equation to calculate the full count. Okay, so he was supposed to take the count for y number of minutes, but because of the break, he took the count for x number of minutes. So if you want the full count, then you will take v, which is the number of which is the count which he is giving you for x minutes, divide by x, so it will become per minute, multiply by y, so it will become for y number of minutes. Okay, and if you are giving him alternate breaks, then you will use the second method, the second equation. So you already have the count before and the count after, and you have a break between them. Right? To get the number in the middle, you will simply take what? Average. Clear? Okay. Then we have this example. Okay, so in this example, if you look at the first column, we have a highway, 2 directions. Okay, so you can see the data is given for both directions. Okay, some data is given for both directions. Each direction has how many lanes? 2 lanes. Okay. Clear? So we have 2 lanes in each direction and the data is taken for both directions. Now you look at the first column. Okay. For how many minutes the data is taken? 12 minutes. Huh? 12 minutes, right? So the first count starts at 4 and finishes at 4:12, right? Okay. When does the next count start? 4:15, right? So there's a break. Break for how many minutes? 3 minutes. Okay, in these 3 minutes you don't have any count, right? So it's a break. Clear? Okay. Now, if you look at the numbers, so this is what I can get from just looking at the timing. That there's a 3-minute break. If you add the 3-minute break, the total period becomes what? 12-minute count and 3-minute break. Total is 15, right? So the total period was 15 and yes, 15. And there was a counting period of, there's a break period of 3. Okay, so you have to take care of that break period. And then if you look at the numbers, you see there's a number here, and then there's a gap. Then another number, then a gap. Okay, so there are gaps now in between the numbers as well. Every lane has it. Every lane has the numbers and the gaps, right? Okay, and they are alternate. Okay, these gaps are alternate, right? We have a number, then a gap, then another number, then a gap, right? Okay, why I'm calling it as a gap? Why not a break? It's not a break, right? This is a gap because he was counting actually here as well, but he was counting in the other lane. Okay, so I will not call it a break. Break is, okay, when the poor guy was just enjoying himself, having some time to himself. Okay, that is a break. But here it's a gap. It's a gap in the observation. For this lane, it's a gap. For this lane, we have a number. So it's not a break. Okay, the observer was not free. He was actually counting in the other lane. Got it? Okay. Why did we do this? Why didn't we ask him or her to count both lanes at the same time so there would be no gap? This is done because of the accuracy. If you are counting 2 lanes at a time, one person counting 2 lanes at a time, you may have vehicles going together. Okay, so the chances of errors are higher. Okay, in recording there could be higher chance of errors because now he has to look at 2 lanes simultaneously. So he may be recording the number from one lane, missing the other lane. It can happen. Okay, but if he is doing only one lane at a time, one lane means one vehicle at a time, right? Got it? Okay, clear? Okay, so this is a gap which we have introduced just to make sure that the numbers are accurate. Clear? Okay, we don't want to do simultaneous lanes, it will have more errors. Okay, so first thing we will do is take care of the break. Okay, so I have eastbound, lane 1, lane 2. I have westbound, lane 1, lane 2. And then I need a column for time as well. Okay, so my time is 4. Okay, so for example, which value you have for 4 to 415? 360, but it's 4 to 412, right? I have to convert it to 4 to 415. So it is 12 minutes, I have to convert it to 15 minutes, right? Okay, so 360 what should I do? Multiply by 15 over 12. Okay, clear? Any questions? How much? Okay, will this change for any number, any other number? For any other value, will this approach change? No, right? All numbers are 12 minutes and all numbers I want it for 15 minutes, right? So whatever numbers you have in the first table, you have to convert all of them into 15 minutes using the same method. Okay. Okay, start doing it. Okay, how much for 350?
438.
Okay, how much for 380? 370?
555.
Huh?
460.
463. 463. Okay, 345.
431.
340.
425.
320.
400.
Okay, 310.
388.
25.
356.
330. Huh?
413.
300. 3.
425. 350.
350.
Yeah.
310. 388. Last one, 260.
325.
Any problem in this one? All were 12 minutes, divide by 12. We wanted 15 minutes, multiply by 15. Clear? Okay. Now how to fill the gap? So there's a gap between these two numbers. What should I do? I take an average. Okay, how much is it?
463.
Okay.
450. 463. 447. 444. 416.
Okay. Next one. 356 and 375.
366.
These two.
401. 419.
419.
363. 407. 338.
Any problem up till now?
First value.
Yes.
L1.
Yes.
How calculate?
I'll tell you.
There is an equation for it.
Mhm.
Something else.
Yes, something else. Any problem? Up till now, any problem? Clear? Okay. 12 minutes to 15 minutes, then there was a gap, fill the gap with an average. Okay. Now the problem is with the first and the last numbers. Okay. Every column either has the first value missing or the last value missing. Okay. Now I cannot take an average because for average I need numbers on both sides, right? I have only numbers on one side. So I cannot take an average. So what do? We use the difference between the two next two values. We use the difference between the next two values. Okay. Now if you are talking about the first value, column number 1, the next two values are these two, 438 and 450, right? Okay. So I will calculate this one using these two values. Okay. If you are talking about this value, the last one, then the next two numbers are these two, 444 and 425. Okay. So next two numbers are either the two numbers before or the two numbers after. It cannot be both, because if you have both, then you will take an average, right? Okay. So I said we will use the difference between the next two numbers. The difference between these two numbers is how much? 12. So the difference between the next number should also be 12. Okay. Now 12 minus or plus? Minus. Why? Because it is, you can see, minus. Okay. So we will apply the same difference with the same sign. This is minus 12. So the next one will also be minus 12. So how much will it be? 4 to 6. If you want to remember it as an equation, then you can say x. So 4 to 6 is my x. Okay. And then you say yeah, a plus a minus b. So a is this number, okay, and b is this number. Okay, you can remember it as an equation, but I told you the difference. It's all in the difference. You take the difference between the two numbers, whatever the difference is, you just apply it to the next one. Okay, so the difference between these two numbers is how much now? 19. So the next number should also have the difference of 19. Okay, plus or minus? Minus, because again you can see the numbers are decreasing. So how much is this? Okay, same thing here. How much? Again it's minus and minus 10. So now it's 446. Okay, this one also minus how much? 3? 346, yes. And this one is how much?
360.
Yeah.
And to final value is 419.
Which one?
That's right.
Oh,
24 minus 25.
is 19.
Not 6.
Huh?
419, not 6.
425 minus 19 is 406. Okay, clear? Clear? Okay. One student told me another approach which will give you the same answer. Okay, which is what we were doing. We're taking average, right? Average of two numbers should be in the middle, right? So if you take average of this one and this one, you should get 4 to 5. It will also give you the same answer. Okay. So average of this plus x gives you this. So you already know this and you already know this, you want x. You can do it in this way as well. It should give you the same answer. Obviously we are doing plus minus here, and when you take an average then there could be plus minus 1 because of rounding off. Okay. Clear up till now? Any problem? Okay. So for the data, we have done the first part. Okay, what was the first part? For every time interval, find out 15 minutes count. For every lane and for every time interval, find out 15 minutes count, which is what we have done. Every lane has a 15-minute count and there is no gap now. Clear? Clear? Okay. The second thing is find out peak hour volume and peak hour factor for each direction and the freeway. Freeway is a type of highway. Okay, freeway is a type of highway. So what they mean here, do it for each direction and then do it for the combination of direction as well. This is what they are saying. Okay, so if they write freeway or highway, means the same thing. Meaning what? Combine both directions. So now they are saying do it for each direction and then again do it for the combination of directions as well. Clear? Clear? Okay. Now these numbers are for each lane, right? So I need to calculate for each direction. Okay. So give me the total of each direction. 876. Next. 901. 901. Is not correct. Replace it is right. 925. 9. Your numbers are different, huh? Yes. 806. Okay, for the westbound.
734, 757, 779, 794, 788, 757, 726, 694.
Okay. Now for the freeway, it's a combination of both directions. Okay. So you just add the totals. Okay. The totals which you have already calculated. How much is it?
1610, 1658, 1704, 1726, 1698, 1632, 1567.
Wait. Yes. 1698 then?
1632. 16.
Okay.
1567. 1500.
00? No. How much is it? Okay, fine. Okay, so up till now we have just added the numbers. That's it. For each direction, add 2 lanes, and for the freeway, add both directions. Clear? Okay. Now, they are asking for peak hour. Okay. They are asking for peak hour. Which hour is the peak hour? 11 to 12, right? Yes. The class time, right? Yeah, tell me, which one is the peak hour? What do you mean by the peak hour? Maximum volume, right? The hour which has a maximum volume. The hour which has a maximum volume. So I cannot tell it now. Because all values are for 15 minutes. So from these values I cannot tell that which hour has the maximum. Okay? Multiplied by 4, it will become flow rate. We don't want this. We want hourly volume. You don't multiply. We will see which hour has a high volume. Okay, so we have 15 minutes intervals, right? We have 15 minutes interval. I am being paid to say. Okay? And you are paying me to shut up. Okay? And you are paying more. So Each value is for 15 minutes, right? So how many values make up an hour? 4 values. Okay. So we will add the 4 values to get the hourly volume. Okay. Okay, so if I add the first 4 values, how much will I get?
3634.
3634. Okay, now the first 4 values means what is the time of this number? 4 to 5, right? From 4 to 5. Okay, I can add the next 4 values. Next 4 values meaning what? These 4 values. From 901 to 910. Okay, these are also 4 values, right? Every 4 value will make an hour, right? So if you add these 4 values, then how much do we get?
3668.
Now what is the timing of this volume? Very good. Okay, 4:15 to 5:15. Okay, I mentioned in the previous topic as well when you were discussing annual. So annual can start from any date, but you have to complete the year. That makes an annual. Same thing here. The hour can start from any minute, but you have to complete the hour. So it can start from 4, the hour is completed at 5. It can start from 4:15, the hour completes at 5:15. Got it? Okay. Next 4 values. 3642. Next.
3558. 3432.
Okay, we will do the same thing for the other direction as well. Okay, tell me.
3064. 3118. Same. 3065. 2965.
Okay, and we will do the same thing for the freeway as well. For the freeway, you don't have to add 4 values. You already have for each direction. Just add both directions. Okay, so 3064 plus 3634. 6 what? 66.
6698.
Next. 3118 plus 3668. 67986. What happened? You were saying something? 3118 again and 3642. 6767. Next. 3065 3558. 23. Next. 2965 and 3432.
6397.
6397. Any problem up till now? Clear? Clear? Okay. Okay, now they are asking for the peak hour volume and the peak hour factor. Okay. So if I am doing it for the eastbound, Okay, which hour has the highest volume? Tell me. Yeah, the second value, right? 3668. Okay, so the first value was from 4 to 5. The second value is 15 minutes after that. 4:15 to 5:15. Okay, so 4:15 to 5:15. What is the volume? 3668. Okay, we also need the peak hour factor. Peak hour factor, there was an equation, V divided by 4 times VM15. Now, what is V and what is VM15? What was it? What was V and what was VM15 in the peak hour factor equation? V is the total volume, yes. 15 minutes. Flow for 15 minutes. Okay. Which 15 minutes? Huh? For the peak hour, yes. But the peak hour has 4 intervals of 15 minutes, right? Average. M means what? Huh? This VM15, right? So M means what? 15 minutes is for 15 minutes. Maximum. Okay. So you will look at the 4 intervals of the peak hour and pick the value which has the maximum. Okay. So I am picking this peak hour, right? So these are my values. Okay. And the maximum is 932. Okay. Now let's say there's a value here. On the last row, there's a value of 1000. Can I pick this one? No, because this is not part of the peak hour. You cannot take volume from 1 hour and flow from the other hour. You cannot do that. So even if I get a value of million here, I will not pick it because this is not part of my peak hour. So the VN15 has to be part of the peak hour. Okay. So in this case, 3668 divided by 4 times 932. How much is that? Clear? Any problem? Clear? Hmm.
What does this value mean?
What?
The value we got, what does it mean?
Which value?
0.9.
What does it mean?
Factor of safety.
Factor of safety for what?
For peak hour.
For peak hour? Why do we need it? Why do we need it? Why? If I don't do it, if I don't include this value, what will happen to one? Will have Q because of? Because of what? We did an example, right? There was an example. You are right. In that example, we did not consider the factor, and there was a Q. But the Q happened because of what? The variation in the hour. This factor gives you how much variation is there in the hour. Okay, so 0.98 means very less variation. 1 is the perfect value. 0.98 means very less variation. But we consider it in the design. If you don't consider in the design, if you use the design volume without the peak hour factor, yes, you will have a Q. Within the hour, there will be a 15-minute interval which will generate the Q. And you are not sure whether this Q will remain till the end or not. Okay, for more details, go back to the example which we did in the first chapter. After that, there was peak hour factor. Okay, for westbound, which volume is the highest? There are 2 values. Okay, if this is the case, you can pick any value, no problem. This is the case, you can pick any of the 2 values. Okay, but there are other criteria. If I pick the first one, if I pick the first value 3118, my timing is what? 4:15 to 5:15, right? Okay, which is these 4 values from 757 to 788. What is my maximum flow? 79. Okay. If I pick the next one, which is 4:30 to 5:30, then my values are from 779 to 757, right? Okay, what is my maximum flow? 79. So the maximum value is not changing, the maximum flow is not changing. You can pick any of them, no problem. Okay, if this, obviously, if the maximum value changes, then the maximum value becomes my peak hour, right? If one of them is giving 3120, that will become the peak hour, then there is no question. But if you have 2 hours having the same total, then you look at which hour has the maximum flow. Let's say if this was giving me 794 and this one was giving me 800, so I'll pick this one. Clear? Clear? So if the totals are same, then you will look which one has the highest maximum flow. Okay, in this case there is no problem. So I will just keep 415 to 515. Okay, and the value is 3118. The maximum flow is, and the value is same. Sorry, two decimals. Okay, for the freeway, where is the maximum? 6786, right? Okay, 6786. Six, 7, 8, 6. The highest flow is 1726. And the value is same. Okay. Now each direction has its own numbers, right? Okay. So the peak hour factor can be different. Values are different. The values are different. The volume is different. The maximum flow is different. But the peak hour factor and the time of the peak hour can also be different. Each direction can have a different peak hour, no problem. Okay, so there is no rule that both directions will have the same peak hour and both directions will have the same peak hour factor. There is no such rule like this because each direction has its own numbers. So when you put different numbers, you can get any answer, right? Okay, but obviously this is a book example, so this generates the numbers. This is what you are getting in the end, but there is no rule. Okay, so you cannot assume that this one was 0.98, so this should be 0.98. Or this one was from 415, so this should be also from 415. It can be from any time and any number. Clear? Clear? Yes.
When we make calculation for freeway, I think it's enough to take each direction separately only.
Because they said so. Okay. Now look at the last one. Last part C. Okay, they're asking for flow rate. What is the flow rate?
Flow turned
Conversion to hour.
Yes.
flow turned into 1 hour.
Flow turned into per hour. Okay, flow is for 15 minutes in this case. When you convert it to per hour, it becomes flow rate. Okay, so you can take the value of each 15 minutes and convert it to its flow rate. Okay, in this case, each value is for 15 minutes. If I want to convert it to flow rate, I will do what? Multiply by 4. Each hour has the 4 intervals, right? Okay, so they are just asking it to do it for each direction. Okay, so you take the value for each direction, which you already calculated here. Okay, this column, okay, and this one. Okay, so you pick each value from these columns, multiply by 4. Okay, easy, clear? Okay, these are the values. You may have some differences, plus minus 1 or 2 here, there, because of the rounding off, plus minus 1 or 2 in the last digit. Okay, Plus minus 1 or 2 in the last digit is okay. The number is 876. You are getting 776. You say no, it's plus 1 or minus 1. No. Okay, it's the first digit, so it becomes plus 100. Okay, so this is not allowed. Clear? Okay. Okay, so we are talking about manual studies. Manually, we can also do speed studies as well. Okay, if you are doing a speed study manually, then what do you use? Yeah, so you will have a stopwatch, okay, and then you need a distance as well. Okay, so the distance or the part in which you measure the distance and time, that part of the road is called as a trap. Okay, it's called a trap. So the car enters the trap and you record its time, then you do distance upon time. Okay, clear enough? We can also do manual studies using speed guns or speed radars. These speed guns or radars, can be handheld. You keep them in your hand, or you can install it on a stand. Okay, but if you are using the radar, then why do we call it manual? Because they are operated manually, same as stopwatch. Stopwatch is a device, right? But you have to operate it. It will not record the time by itself. So if you have a speed gun or a radar which you have to operate, the car passes in front of the radar and does not record. You have to press some button, you have to do something, and then it will record. So it's still manual. Okay, so if you are using a device that needs manual operation, we will still count it as a manual study. It is still a manual technique. Clear?
It says fixed mounted. So
Yeah,
it's
so
fixed.
fixed.
Is it still manual?
Yeah, fixed mounted on a stand. Yeah.
Why it is not semi-automated?
What?
Why it is not semi-automated?
Semi-automated is something different. We'll talk about it. Okay, but it's not semi-automated because for each, if you have a device where you have to do something for each observation, it is manual. Whatever the device is, stopwatch, speed gun, whatever, mobile phone, it's still manual. Okay, if you are using the stopwatch, then you can have two types of errors. One is the manual operation of the stopwatch, the other one is the parallax error. For the parallax error, I will show you a figure. But let's talk about the second one, which is the manual operation of the stopwatch. So the car enters, okay, and then you have to press a button and the timing will start, right? In pressing of the button, you can be little bit late or early. Okay, because you observe when you press, right? Okay, maybe you were looking at somewhere else. Okay, looking in your phone or whatever. Okay, so it may happen that the car already came into the lane slightly and then you started. Okay, or since you are late now, so next time you are very excited. So you do it a little bit early. The car hasn't started yet and you already pressed the button. It can happen, okay? And I'm talking about a difference of 1 or 2 seconds. So you may not even feel it. Okay, you may not even feel it. But the good thing about these errors are they should happen randomly. If you are doing your job correctly, properly, okay, then they should happen randomly. When they happen randomly, then some of the errors will be plus and some of the errors will be minus. In the end, when you take the average or the mean, they will cancel out. Clear? So we have this problem, but this problem can cancel out if you are doing your job properly. So these errors will happen randomly. What is a parallax error? Parallax is related to the line of sight of the observer. The line of sight of the observer. Okay. So you may have also heard about it in surveying, but you don't remember, which is very good. So parallax error happens because of the line of sight of the observer. Okay. How does it happen? You look at the top point on the picture here. That is the position of the observer. Okay, and you look at the line, that is the entry line of the trap. Okay, so he is looking at the entry point direct, straight. But when he looks at the exit point, his line of sight is not straight, it's inclined. Okay, so you look at the line of sight, inclined line of sight, So when he is looking at something straight and an object comes in this line of sight, he exactly knows where the object is. But when you are looking at something with inclined line of sight, there's a little bit of error in what you are seeing and what is the exact location of the object. This is called as parallax. So when the car is here actually, but according to his line of sight, the car and the exit point are aligned. Okay, so according to this alignment, the car for the observer has reached the exit point. This is the parallax error. Now what this parallax error will do? You will do speed upon, distance upon time for the speed, right? Distance upon time for the speed. So which distance the car has crossed? D or D effective? D effective, right? Okay. So the time you recorded is for D effective. So to calculate the speed, I should use D effective. How to get D effective? Now you look at D1. D1 is the distance between the car or the road and the observer. D1. And delta is the angle which is made between the D1 and the exit line, the entry point and the exit line. So you have delta. If I give you delta and D1 and ask you for D effective, what would you do? If I give you D1 and delta and ask you for D effective, what would you do? 10, right? So 10 delta will be D effective upon D1. 10 delta will be D effective upon D1. Okay. So if you look at this example, we have a trap which is marked for 400 feet. Okay. For this trap, the observer is 60 feet behind the entry point. Okay. 60 feet behind the entry point. Which distance is this? D1. Okay. And from this point, he is making an angle of 60 degrees to the exit point. From this location, he is making an angle of 60 degrees to the exit point. Okay. So this is my delta. Okay. Now this observer from this position records a time of 8.3 seconds. For a car, he records a time of 8.3 seconds. Okay. Now, in 8.3 seconds, the car crossed how much distance? Tell me. D effective. Okay. So if I want to find out D effective, then I will use 10, right? So how much is D effective? Okay. And if this is the distance, then how much is the speed? How much time he gave us? 8.3 seconds, right? So 103.9, the distance, and the time, 8.3 seconds. How much is this? This is for the time being, feet per second. We are not required to do any conversion, so this is it. Okay. Now if you want to cancel out the effect of the parallax, then D effective should be equal to D, right?
Yes.
So you have the equation. You can see which values will make them equal. D effective and D. Okay. You can play around with this equation and see which values should I put here to make D equals to D effective. It will cancel out the effect of parallax. Whatever the distance is what we are observing. But you have to look at the practical aspect as well. Maybe you will come out with D1 equals to 1000 feet. And then you don't have the space on the road to stand 1000 feet behind. Okay? Or the angle comes out to be more than 90. Cannot have it, right? Okay, so you have to keep these things in mind. Yes?
How do we measure the angle umbrella?
Angle, you fix your position from where you will stand. And from this position, take a theodolite and point it towards the exit point. You will get the angle. Okay? Okay, clear? Any other question?